Hello mga person, in this video I will be discussing improper integrals. So by definition, it assumes that a function f has a singularity at x is equals to a. So if the limit from a to b f to the quantity of dx as the limit a approaches to a positive does not exist or is not finite, the improper integral from a to b f to the quantity of x dx is diverges. Later on, I will be emphasizing the difference between convergent and divergent in improper integral. So let's proceed. Type 1. Infinite integrals. That is the improper integrals from a to infinity f of x dx and from negative infinity to b g of x dx are called convergent if the corresponding limit exists. So the limit is convergent if there is a corresponding limit, and it is divergent if the limit does not exist. So what is improper integral? It is a definite integral evaluated to positive or negative or both of a definite integral that is discontinuous, for example, has a vertical asymptote over the interval. So there are two types. First is the limit goes to positive infinity or negative infinity. The integral represents an area under the curve. Some converge, or that is what we call finite area, and some don't converge, or that is infinite area. Don't converge, that refers to divergent. And for the second type, that is the integral is discontinuous. So we could say that the integral is discontinuous if, for example, integrals from 0 to 2 1 over x minus x dx, and that is not defined at x equals to 1, because if we substitute x into 1, our integral would be equals to 0, and that means the integrand is discontinuous. Another example, from integral of 0 from 0 to 5 ln to the quantity of dx, the quantity of x dx, that is not defined at x equals to 0, because if we substitute x equals to 0, that would be the limit is not defined, so that is divergent. So improper integrals, for example, integral of the integral of e to the power of negative x over square root of x dx from 0 to infinity is improper because the integrand has a singularity and the interval of integration is infinity long. So our integration here, that is clear that it is infinity, and that means that it is improper.